Hi everyone, in this video we're going to go ahead and graph a transformed secant function. So to begin, what we should be doing here is identifying some of the key components that make this graph what it is. So specifically what I'm referring to would be if we, say, took a look at the 2 out in front, we would note that this would be our amplitude. The next item that we might want to note here is the -1 that's on the outside of the function itself. So this is going to be our midline. And that tells us that we are moving down 1 unit. Let's move into the interior. So I see that I have a +3 next to my input variable. And this is going to tell me what my horizontal shift is. And again, since it's inside, we want to remember that this is referring to a house of lies. So this is telling me that I'm going to move to the left 3 units. And lastly, we have a horizontal compression of pi. So what we want to remember here is that it is the b, so in other words, our horizontal compression is represented by the variable b. So this is not our period. We need to use this component in order to figure out what the period is. So in this case, we know that since we are working with the secant, its period is 2 pi, and we're going to divide that by p, or remember that we can change this over and say that p is equal to 2 pi divided by b. If we do that, then we can go ahead and substitute what we know b to be. So that would be 2 pi divided by pi, which simplifies down to a period of 2. So again, since we're dealing with a circle, we basically want to use this item here, so this 2, in order to figure out how we should scale our horizontal axis. So because we're dealing with a circle, essentially, and a circle contains 4 quadrants, I'm going to take that 2 and break it into fourths. So in other words, my scaling should be 1/2. So in other words, if I were to label my axis, that would be 0.5, that would be 1. I'm just going to go ahead and skip around so that we can kind of see how everything is laid out and that I'm not crowding my image here. And I'm actually going to go ahead and get rid of that 0.5 so that we don't have to look at that. And again, crowd it and get rid of all these extra dots here. Sorry about that. The screen can sometimes get a little sensitive. Okay, and then we'll go ahead and we will label our vertical axis. And actually, it looks like the -1 is kind of conflicting where it is, so I'm going to go ahead and just write every other number in there so that it's not too crowded from what we're looking at. 2, 4, and 6. Okay, so let's go ahead and start labeling and building our infrastructure in order to get this secant function down. So one of the first things that we're going to want to note here is I would start with the midline. So we know that the midline is down 1, so I'm going to go ahead and sketch that midline in so that I can see it, and I know how the shifting has taken place. Okay, so now what we want to do is we want to know that we can treat this, or we can look at it from the traditional perspective of the inverse of secant. So in this case, it's cosine. So we know that a cosine is going to start at the top, and a cosine has an amplitude. This cosine has an amplitude of 2, so I'm going to go up 2 units from the midline, And again, because I've already set my period to be 2, I've been able to to determine my scale should be 1/2. So I know that at the next interval, so at 1/2 here, I'm going to go return back to the midline. Then at 1, I'm going to go down 2 units. At 1.5, I'm back to the midline. 2, I'm up 2 units. But I'm actually getting ahead of myself because I have to take into account the fact that I've moved everything to the left 3 units. So what I did was I was premature. So let me kind of take back those points. So what I'm telling you is that a traditional or a usual or an unshifted cosine function would have started on the vertical axis above the midline. But since we have a +3 inside the function, we're told that we moved everything to the left 3. So I actually want to take this point that you're seeing here, and I want to move it over 3 units. So actually, I have to move it over here. So please remember, like, don't think that, well, why wouldn't I move it here? Because don't forget the scaling that we used. So if you left it here, yes, it looks like you moved it 3 tick marks, but the way that we have our scaling here, we've actually only moved it to the left 1.5 units. So that's why I don't want it to be there. I actually want it to land here. So let me clean up my board here so that we're not too confounded. So again, I actually want to start here. So again, because we're dealing with a secant, and a secant is the reciprocal of a cosine, I want to start above the midline. And I'm also going to not only start above the midline, but I want to move everything to the left 3 units because of that horizontal transformation. Hopefully that explanation is clear and that I haven't lost you. So now we can kind of, for lack of a better term, go on autopilot, because again, we've established what the scaling should be, and we purposefully put that as what we need for our horizontal axis. So at the next tick mark, I'm going to return to the midline. Then going from -2.5 to -2, I'm going to go to below the midline to deal with that amplitude of 2. The next tick mark, we go back to the midline. Then when we go to -1, we go to 2 tick marks above the midline, back to the midline, to below the midline, midline, to above the midline, back to the midline, to below the midline. I think that you all get the picture of what I'm trying to do here. So I'm just going ahead and I'm going to sketch this graph from end to end. So again, I don't necessarily want to do a solid line here because we're not trying to graph a cosine function. We're trying to graph the secant. So we have all of this established. Hopefully that looks good. Now we need to incorporate the asymptotes here. So if you recall, if you were to say look back at a standard secant function, the asymptotes, the vertical asymptotes that you're looking at, they occur at the where your invisible cosine function crosses that midline. So we actually have one asymptote at this point going through -2.5. Then we have another one at -1.5, -1/2, +1/2, +1.5, +2.5, 3.5, and so on. So at this point, we've laid the full structure out. We don't really need anything else here. We're ready to go ahead and assemble what this function is going to look like if we were to sketch it roughly. So again, we can take a look at where the points are that our amplitude kind of placed at. So in this case, I know that I'm only going to touch that maximum point on the cosine, and I'm going to go ahead and I have a U shape here. The next one, since I am below the midline, this one is going to kind of create like a lowercase n. This one is going to produce the U, lowercase n, the U, and they're just hugging the sides of the asymptotes. All right, and there you have it. That is our rough sketch of our secant that's been transformed 3 units to the left. So a couple other things to note here. We can go ahead and identify, say, the range. So notice here that the range, we do have something going from, it looks like, let's see, -3 down to -infinity, although we always want to write that from the smallest number to the largest. And then we're going to union that. So we union this because technically this area here is dead space. Nothing is existing there. So it looks like we start at +1 and then go off to +infinity. So those are all the output values, or in other words, the values on the vertical axis that we're using here. So then we can also talk about the domain. And this one might be a little bit more tricky, or maybe not, maybe tricky isn't the right word, but maybe just requiring a little bit more thought. So if you were kind of listening when I was establishing the asymptotes, it sounded like every time I was saying, okay, you can't have it at -1/2, you can't have it at -1/2, you can't have it at +1/2, or anything along those lines. So it sounds like our x values, we can simply, it's going to be easier for us to uncover what can't we use. Okay, so, and we ideally want to do this in a closed form. We don't want to list these out because technically the number lines go off into infinity and -infinity. So we technically shouldn't just list them out because we would be doing it forever. So if we're looking at this one, we basically can say, well, I know that I can't use 1/2, and then I can't use any iteration of it. So I can't do 1/2, and then I cannot add an additional number to it. And then again, we need to identify what k is. So I'm going to say where k is an integer. Because if you think about that, if I put a +1, then I have 1/2. If I put a 2, 2/2. So I'm able to list out all the positive values. And likewise, I can do the same thing if I start using negative numbers instead. So if I put a -1 in there, then that would result in the -1/2, and so on. So we've basically generated a full picture of what this graph looks like, as well as what inputs we are allowed to use and what outputs we will get from using those specified inputs. I hope this video was helpful. If not, or if you see any kind of mistake, or if you're seeing a spot where more explanation should be provided, I encourage your feedback. So thank you very much.